All right, it's the second to last day of class. We're almost done, right? Huh? It's Friday. Good weekend. Time to do some problems. What's going to happen Monday? We're going to review. And unfortunately, I've already given you my best material. If you want to review something, what should you do? You should email me. You should email me, and then I will try to do the problems. Or I'll say, no, I don't want to do that problem. Right. Okay, so perhaps what I'll do today is I'll do just a little bit more substitution, some more substitution problems. Does that sound all right? I don't want anybody to miss this on the exam. I mean, whatever. Yes? He says, how could the question be worded for substitution? If I was a betting man, I would bet they would word it as compute this, and then they'd write down an integral. I am not kidding. That's how I expect it to be worded. All right? And then after that, after I work a few of these problems, I'll work another problem where you can kind of maybe see another way it could be worded. But the first way you should expect it to be worded is compute this. All right. Oh. Yeah, let's do this one. I don't think I did this one in class the other day. Let's go ahead. I have no idea if I did this one. If I didn't do this one's a good one. Let's do it again. All right. So how about the integral of secant? This is the indefinite integral. Secant 2 theta tan 2 theta d theta. Did I do this one the other day? Oh, stupid me. Well, just talk me through it real quick. U equals 2 theta. Du equals 2 d theta. Theta is the variable, not x. Ha 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 ha. Okay. 2. Wait. Du. There we go. D theta. All right. We good now? Excellent. Now what do you do? If you have no idea what to do, what do you do next? You solve for d theta. If you have no idea, divide both sides by 2. So d theta equals 1/2 du. And then you plug these things in. And you see that this is equal to the antiderivative of secant u tan u times 1/2 du. Is that correct? Yeah. The 1/2 can go out front. It's a constant. You can always pull a constant out front. And what's the antiderivative of secant tan? Secant u. Secant. Yes. Know that. That's a good thing to know. Equals 1/2 secant u plus c. And are we done? Go ahead and plug u back in. Equals 1/2 secant 2 theta plus c. Right? All right. Let's do, well, I probably did that one. Let's just see if I can find one that I didn't do. Okay, here's one. These, I know I didn't do these. Let's do these. Good. What questions do you have about this? What's the hard part about this integral? Figuring out u. Figuring out u is always tricky, and there's nothing. I can only give you rules of thumb. I can't tell you how to do it every time. What's the other hard thing about this integral? Remembering that the derivative of secant theta is secant theta tangent theta. Remembering that fact. If you don't know that fact, do you stand a chance? No, you don't stand a chance. What do you need to know for your exam? You must know the derivative rules. You have to know the derivative rules. Are we going to take it easy on you with the derivative rules? No. It will approach unfair. It will be fair because we're going to do it to you all the same way. It's not going to be fair because you're going to be like, why couldn't you just ask me one of the easy ones to see if I understand? Why'd you ask me the hardest one you could think of? I don't know. I didn't do it. Okay? Sorry. We're going to review on Monday. But I'll give you some advice for studying right now, okay? Here's how I would study if I were you. I would ask myself, I would imagine myself in the exam, taking the question, answering the questions, and think, what's going to make me really mad at the end of the day? And what would make me the most angry is if we asked you questions just like your midterm questions and you missed them, right? Wouldn't that make you angry? You have to make sure the first line of defense for you is making sure that if we have the audacity to ask you any questions that we previously asked you, you get them right. Make sense? You can't let those slide. If it happens, you must say, no, I know this one. Bam. Okay? That makes sense? That's your first line of defense. Next line of defense is you do the review problems that we sent out. There's like, I don't know what it is, but there's some questions that we emailed you all, right? It's on the Math 151 website. She's nodding yes, good. I'm not lying to you yet. Let's see, the next line of defense is I have all those other exams. You could try to do those, right? Is there anything else you could do to study? Yeah, book, homework problems. You could do previous homework problems. I don't know how much those will help. I really don't. Those are kind of in the order of what I think will help the most, right? And if you email me questions, I will do them or not. Okay? If I decide not to, that's probably good. Don't email me like 20 problems. Email me like, well, I don't care what you do. Okay? Just if you email me problems, that's great. I'd love it. Okay? Or even problems from the previous exams. That would be good, right? You say, Bart, do this problem from the previous exam, and then I'll do it, and I'll talk about it. All right? Please. It'd be great. It'd be great for you. It'd be great for me. It's a win-win situation. All right. Here's an integral that looks hard. I don't think I did this one last time. This one's a trick question. Because I would not use substitution to do this one off the bat. What I would do is I'd start and then I pause and I say, shoot, I'm not real sure what to do here. And then I'd look at the numerator. What do you see in the numerator here? A factor of the denominator? Is that a factor of the denominator? Yeah, I guess it is. No, I don't know. Integrals are additive. And I know that this is sort of a math person term when we say additive, but it means if we can find things where we add things together, we can break them up. And so this is equal to the integral of 1 over 1 plus x squared plus x over 1 plus x squared dx. Right? Adding fractions here. This is now equal to the integral of 1 over 1 plus x squared dx. You can separate it out when it's a plus sign. Only when it's a plus sign or minus sign. Plus or minus equals 1 over x over 1 plus x squared dx. What's the antiderivative of 1 over 1 plus x squared? That's arctan. This one you can do as arctan. This one here, does anybody know what this one is? Maybe we should use substitution to do this one. Maybe we should use substitution to do this one here. Can anybody tell me? Can anybody just tell me what this kind of looks like? Can anybody say, well, it's going to be something like, what? Something like natural log. It's going to be something like natural log. That's right. Something like natural log. I'm happy with that answer. Something like natural log. Let's go ahead. And so this one is equal to, arctan. This one's a little bit more complicated, so I'm going to focus on this one. I'll write a final answer at the end, and I'll box it in. You'll know it's my final answer because of the box. Okay? So now, I'm just focusing on this. X over 1 plus x squared dx. U is equal to 1 plus x squared. Du is equal to 2x dx. Dx is equal to 1 over 2x du. You don't have to put so many steps in, but I do because I'm trying to help. So now, substituting in, well, we have the integral of x over u times 1 over 2x dx. What happens to the x's? They cancel, right? So this is equal to 1/2 the antiderivative of 1 over u. Oh my God, what am I doing? Du, sorry. Du. And what's the antiderivative of 1 over u du? Natural log of absolute value of x, isn't that right? 1/2. Like that? Oh, you, Bart. You. Oh, that's so nice, because tell me about 1 plus x. Tell me some fun factoid about 1 plus x squared. Always positive. That's exactly, he read my mind. It's terrifying, right? It's always positive. So this is equal to 1/2 natural log of 1 plus x squared. And if you were unsure about these absolute value signs, you could just erase that line and go directly to here. And we would never be the wiser. So anyways, let's put the final answer down. Putting in the final answer, the antiderivative of 1 plus x over 1 plus x squared, worst x ever made, dx is equal to arctan of x plus natural log of 1 plus x squared all over 2 plus c. And I promised you to box it in, so there we go. What questions do you guys have about this? This one was kind of tricky. Oh, yeah, back there. Okay, he says, would it be perfectly acceptable to do the substitution right from the start? Yeah, let's try it, okay? Me, I'm a timid creature, and I'm afraid to do that because it's not going to work. But maybe it will work. So let's try it out and just see what happens, okay? Because you might say, why would you do that, Bart? Why would you ever try something that's not going to work in front of people? Well, it might work. I have no idea what's going to happen. I just don't see it. I'm not savvy enough to tell. So let's see, 1 plus x. You're talking about this, right? Dx. And now, do you know what to set u to be? 1 plus x. Du is equal to 1 dx. And now dx is equal to du. So now, what's going to happen is this thing is going to equal the antiderivative of u over 1 plus x squared du. How do we get rid of that 1 plus x squared? Yeah? Well, I'll take that in a second. I don't know how. If you guys can see how, that's not because that I'm right. It's just because I don't know how. You understand what I'm saying? So at this point, standing right here, you may go home, think about it. You may see right now and just not want to tell me. But I don't see how to make this work. This might happen to you on the, yeah, what's up? Could you solve for x in the u equation? Sure, you can try to do that. And so what you should do is, because it's not going to be strictly equal, I hear what you're saying.
But I think that you should have started with x squared.
Let's just see what happens, okay? But we're going to get x equals u minus 1. And then she says, aha, so then this thing's equal to the antiderivative of u over 1 plus u minus 1 squared du, right? That's true. And actually this is, no, aha! And now we could use, if we, well, again, I kind of don't know what to do anymore. You understand what I'm saying? This guy says, hey, expand out everything. The antiderivative of u over 1 plus u squared minus 2u plus 1. Okay? And now this is looking pretty good. I'm feeling kind of good about this. Equals du, sorry. Equals the antiderivative of u squared minus 2u plus 2. You have a u up here. And put the du back in there, Bart. Bart, before they fire you for not putting the du in there. You know, if I forget the plus c, they automatically deduct my pay. No, I'm just kidding. I just made that up. That'd be funny. That'd be awesome. No, it'd be terrible. Anyways, so now, let's see. You could guess that this is maybe a natural log of something. So that's looking pretty good. But what's going to happen is it's not, this is going to be hard to differentiate. We kind of got ourselves into a trap again. If this happens to you on the exam, what do? Scrap it. Don't erase it all. Maybe just kind of put it aside and try something else, because you might want to go back to it. Okay? I don't think it's going to work. Now, the question was, what if we set u to be 1 plus x squared? Because that's very tempting. That's what, I mean, I was definitely, these are all tempting things to do. How do you know? How do I know? Sometimes I'll do a problem and I'll just keep on working, and then I'll get the answer. Other times I'll do a problem and I just give up immediately. How do I know that, like, why do I give up so easy sometimes and not other times? It doesn't look right. I've done these problems many times, right? I've done a lot of problems. And so it's like, I don't know, this one looks hard. Okay, let's try this one. It might work. Let's just see what happens real quick. Du equals, I know you guys probably don't like this, but it's good to do. Okay, 2x dx, that's looking okay. What's dx equal to? 1 over 2x du. So now this is equal to, oh shoot. You guys think about what's going to happen next. Something bad's going to happen. So this is 1 over u. That's okay. And then we're going to put 1 over 2x du and put 1 plus x here. But what can't we do? We can't cancel that x. Integrals are very tricky. The ones that we do in class are special. They're the ones that you can compute. If I change this around ever so slightly, all of a sudden it becomes so hard that I say, I don't know. Pretty innocent, right? I don't stand a chance. Okay? This is, I can't do it. If anybody ever says they can do any integral that you can think of, give them that one. They can't. There is no formula. All right, so what was the trick with this one over here? Separate it. And can we separate multiplication signs? No, no. Only addition and subtraction signs. All right? No matter how badly, you can pull constants out. Constants, no matter how badly you might want to pull out through multiplication, never ever do it. It will always be wrong. Well, mostly always. Okay. Let's see. Did I do x squared over the square root of 1 minus x? Anybody know? That sounds like something I would have done. Ooh. We got it. I'm going to do two more, and then we're going to do some physics problems, and then we'll be done. Yeah. Where did I throw that eraser? I put my paper on top of it. Did I do the integral of cotangent the other day? Cotangent is a good one to watch. Let's do cotangent. Because there's a trick. I'm trying to show you all the little tricks that aren't too terrible. Okay, so here we go. The antiderivative of cotangent of x dx. All right, first step, what should we do? Cosine over sine. I hate cotangent. I can barely remember that it's cosine over sine. Equals the antiderivative of cosine of x over sine of x dx. Now you have now we have a problem. So what's u? Yeah, u is equal to sine. U is equal to sine of x. That's a good choice. Why? How do we know not to set u to be cosine? Let's do this same problem, but in a parallel universe over here. So there, you made the right. That was the right choice, and I say this is the wrong choice. Wrong. Okay. They always tell us never to write anything wrong on the board. Well, I'm breaking that rule. Right. Okay. So the wrong choice would be if we're doing the antiderivative of cotangent of x dx. And the wrong choice is a very reasonable choice. That's why I'm showing you this. Let's see, it's cosine of x over sine of x dx. The wrong choice is cosine. At least I say it's the wrong choice. Let's see what happens. I don't know what's going to happen. I'm bad at seeing into the future. Okay, so now, what's du equal to? Derivative of sine is cosine. Even I know that. Cosine of x dx. Oh, the derivative of cosine is negative sine of x dx. Nothing has gone wrong so far. So far, both seem to have an equal say, I think. I mean, maybe I'm wrong. I have no idea what's going to happen here. This is very mysterious to me. Okay, so now, cosine, what's dx equal to? It's 1 over cosine of x du. Isn't that right? Okay, now let's look over here. So now dx is equal to 1 over minus sine of x du. It doesn't cancel. You guys see what's going to happen here? When we plug this in for dx, the sine x isn't going to cancel. That's the problem. That's why. So you're going to get, this is going to equal the integral of u over sine squared x du. Is that what you want to see? No, that's terrible. That's horrible. Over here, this thing's now equal to the antiderivative of cosine of x over u times 1 over cosine of x du. What happens to the cosines? They cancel, equals the integral of 1 over u du. And what's that equal to? Natural log, right? Equals natural log of absolute value of u plus c. Outstanding, c is equal to sine of x, equal natural log of sine of x plus c. That kind of makes sense, what's going on here? When we always show you, my philosophy is that if I always show you the right step, you're never going to see what, from me at least, what happens if you make the wrong choice, you know? And how do you identify if you make the wrong choice? Yeah? Why do we need the absolute value? Well, it's kind of don't need the absolute value. Yeah, sure. Well, you need it because we like real numbers. Can't take log of a negative number and it works out. But it's also kind of right because you can take log of a negative number. You just get imaginary numbers out, and it actually all works. It's fine. It's some pathological thing that if Briggs, Mr. Briggs, Dr. Briggs would have written a calculus book where he didn't do this, then some stuffy old professor would be like, well, I don't know. I mean, I can't use this book because whatever reason. It doesn't matter though. Although log of a complex number is complicated. Okay, so one more. Any other questions about this? Let's do one more problem. This one looks like, if I had to guess, like one that was going to be on your exam. Like I like to put something like this on there, maybe, I don't know. But if I had to guess, this one looks like something that would appear on your exam, sort of. Okay, here we go. This one, here we go. The antiderivative of dt over cosine squared t square root of 1 plus tangent t. There we go. See, look how terrible that looks, right? It looks terrible. First of all, the dt is in the wrong place. Yeah, sometimes we do that. I don't like it. But sometimes we do it, so there we go. You can, yeah. I don't know why. They just feel like that's a good idea. I don't think it's a good idea. But they do that, so you might see it. What's up? Is it okay? You got the question down? All right, what's going to be u? Yeah, use 1 plus tan t. du is equal to, well, what's the derivative of 1? It's 0. What's the derivative of tangent? Secant squared, right? Secant squared t dt, right? Solve for dt. Equals 1 over secant squared t du. Okay. What is secant? Secant is 1 over cosine. So 1 over secant squared is equal to cosine squared t du, isn't it? And now what's going to happen when we plug this back in? What's going to cancel here? It's good, right? Okay, so now, so this is equal to, the dt is equal to cosine squared t du. We have a cosine squared t here, square root of u. These things both cancel. So now we have the integral of 1 over square root of u du, which is equal to the integral of u to the minus 1/2 du. What's the antiderivative of u to the minus 1/2? It's equal to 2 u to the 1/2, right? Plus c. And so our final answer is equals 2 to the 1 plus tan of t to the 1/2 plus c. And I'll box that in. Now, I visited some of your TAs the other day, and it was nice. I enjoyed it. One thing we talked about is when you do this sort of thing, you kind of sometimes you have to change the limits, right? Do you guys remember that? You don't have to change the limits if you plug back in the way I just did, right? Do you know what I'm talking about? If not, he says no. That's very brave of him. If he was on Harry Potter, he'd be in Gryffindor, I think. He's not paying attention now. Yeah, what's up? Yeah, with definite integrals, So what I'm saying is if we put a to b here, you could just evaluate this thing from a to b because we've already plugged the stuff back in. You already have t's there, right? If you have u's in your answer, just plug back in. It's easiest. I'm looking to see if anybody has a question they'd like to ask about that. One thing you guys should work on, I'm gonna propose a radical idea. This radical idea is that emotions are a precursor to intelligence. So like when we have emotions, you know, it's like we don't think about them. We just get angry or something like that, right? Or we get happy. I think you can tie your emotions to different things. So I think you could attach your emotions to calculus. So when you start doing good things in calculus, you start to feel good. That way when you see something, you're not thinking about it. You're just feeling good. You're like, aha, I can use U substitution. Aha, I'm ready to do it. And then you see, you got to control that. You can attach different thoughts to the emotions, and then they can start to carry you through. I think this is true. Prove me wrong. Okay, that's my crazy idea for today. Are we ready to work on something else? Are we through with U substitution? All right. Let me get this. Got my orange ball. I'm not sure if I'm going to do anything with it. I want to do a physics problem. I know exactly what I want to do, sort of. Yeah. No. Okay. All right. So, let's see. The other day I was tossing the slinky in the air. Remember that? How many of you followed that conversation? Only one person just raised their hand. 2 people. Okay. It's a worthy one to have. Let's try it one more time. You're like, no, this is really good. Okay, this is good stuff. This time we have a ball. It makes more sense. Okay. Or no. All right. Or no. Okay. So now, what was the idea? The idea is you have a ball, and what we're going to do is we're going to toss it in the air for about 2 seconds, right? Toss in the air for 2 seconds. 1, 1,000, 2, 1,000. 1, 1,000, 2, 1,000. So, tossing in the air for 2 seconds. What's the acceleration of the ball while it's being tossed in the air? Negative 9.8. Okay, we'll use negative 9.8. We'll get different answers this time. Different answers means different problem, right? Anyways. So, if A of t equals negative 9.8. You guys agree with me here? Okay. 1, 1,000, 2, 1,000. 1, 1,000, 2, 1,000. All right, so I want to know, what I want to know is its average height. I want to know its average height. I want to know the average height. And we're averaging over what? Time. Averaging over 2 seconds, averaging over time, right? I want to know its average height. So v of t, what's v of t equal to? The antiderivative of a of t is exactly right. And the antiderivative of minus 9.8 is minus 9.8 t plus c, right? Plus c. And that c has a real physical meaning. What is the real physical meaning for c there? It's the initial velocity. That's exactly what it is. It's the initial velocity. And so you know what? I'm going to rename it. I called it c there with the intention of reminding you that's what's happening when you're adding that c in when you take antiderivatives. That's all you're doing. So we're going to call it v naught. By the way, what's it called? What's the difference between velocity and speed? Directions. Does speed have direction? No. You can be speeding in reverse too. All right? Maybe that's a good way to remember it. You put your car in reverse. You couldn't like fly down the highway at 120 miles per hour in reverse, and then the police officer pulls you over and says, "Do you have any idea how fast you're going?" No. I was going negative 120 miles per hour. So I was actually driving below the speed limit. You know? Right. Right. They won't buy that. All right? So I mean, supposedly you can use the intermediate value theorem to get out of a ticket too. No, so yeah, the intermediate value theorem. So how often have you guys been driving and you come up to a stop sign and you don't come to a complete stop, right? You just kind of slow down a little bit, right? Well, if you can actually, and sometimes you really, if you get your acceleration to 0, you can still roll through, right? And that's still a ticket. But by the intermediate value theorem, you can make some argument that you had to have gone through 0. Yeah, they don't buy that. Okay, so here's the initial velocity. What's the position? How do we find the position of t? Take the antiderivative again, and this is minus 4.9 t squared plus t times v naught plus, and I'll put p naught here. What's p naught represent? The initial height, right? Now the initial height we know. This is going to be, I'm going to rewrite this. P of t is equal to minus 4.9 t squared plus t times v naught plus, we'll say it's 1 meter. 1 meter high. What we don't know is how fast I toss the ball up. We have no idea what that is, right? We have no, if it's going to be 2 seconds, 1,000, that's too high. 1,000, wait, I'm doing worse. I was good at basketball. No, I was terrible. Okay, so 2 seconds. So if the ball has been up in the air for 2 seconds, can we figure out what the initial velocity was? Yeah, we can. Because what we want to do is we want to make sure, we want to solve well, the easy way to do it, what's the easy way? All right, the ball's been up in the air for 2 seconds. I want to know what the initial velocity is. Tell me the easy way to solve this. Yeah. He answered perfectly. Set velocity equal to 0 when t equals 1 second. Because when you toss the ball up, when does it reach its highest point? 1 second. You come back after 2 seconds, right? 1 1,000, 2 1,000. So its maximum, right? Its maximum is at 1 second. So we can say v of 1 equals 0 equals minus 9.8 plus v naught. So what's v naught have to equal? My 9.8. 9.8. Yeah, but he says, this guy says it's 2 seconds. He's right. But what are we plugging into? Velocity, right? And when I toss the ball in the air, 1 1,000, 2 1,000, it reaches a maximum at 1 second. If it truly takes 2 seconds, it takes half the time to get to the maximum and the other half the time to get down. It's symmetric. It's a parabola. I'm letting you guys know that fact. It's great. Okay, so the v naught equals 9.8. That's fantastic. This is the sort of thing that calculus was made to do. I like going over, I'm really enjoying, I think this is a great problem for us to do again. So v naught is equal to 9.8. V naught is equal to 9.8. 9.8. We're talking about velocity. We're talking about acceleration. Its connection to the derivative, to the antiderivative, right? You guys with me here? How do we compute the average height now? Pay attention to this, because it's very reasonable that on your final they'll say, compute the average value. And what is that? What's the first, if you had to say, I say compute the average, we're a calculus class, compute the average value. What are you going to do? You're going to, are you going to take a derivative? You're going to take an antiderivative. You're going to do an integral. Average value means integrate at some point, okay? So we have to integrate this thing. So if I want to know the average height over 2 seconds, what you do is you do 1 over 2 times the integral from 0 to 2. It's actually 2 minus 0. It's the top minus the bottom. Of minus 4.9 t squared plus 9.8 t plus 1 dt. And then can you do this integral? Is this one that we can do? Yeah, this one should be no trouble at all, right? This one is equal to 1/2 times the antiderivative of, okay, what's the antiderivative of this first term here? Oh, wait, oh, hold on, Bart. No more integral sign. There we go. 1/2. What's the antiderivative of this? Yeah, that's right. Okay. Plus 4.9 t squared, right? Plus t, right? The whole thing evaluated from 0 to 2. So the average height is 1/2 times minus 4.9 times 8 over 3 plus 4.9 times 4 plus 2. And if anybody has a calculator, what's the answer? Without using a calculator, what's the answer going to be about? Is it going to be closer to 1 meter or closer to whatever the top is right here? How about, wait, what is the where are we at? When does this have a maximum? When t equals 1, plug in 1 here. It's 9.8. There should be a point there. There is. 9.8 plus 1 is 10.8. 10.8 minus 4.9 is? Is it 5? 5 stupid math. 5.1, is that right? Yeah, what's up? I'm sorry. Right here? This one is our P naught right here. And it's how high the ball is when you toss it up in the air. See how I'm holding the ball right here? This is supposed to be 1 meter off the ground. It's a little bit more. Okay? It's the initial position that you start at. Ooh, 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 ooh. Well, that's okay. Go ahead. Where did the what? Oh, where did the 8 and 4 come from? I plugged in 2. 2 cubed is 8. 2 squared is 4. That is the final answer. Final answer. And I was asking you, about how much is it? Without using your calculator, is it closer to the top or closer to the bottom? It's closer to the top because it's slowing down, right? It's moving faster down here. It spends most of its time closer to the top of the height. All right, so we'll review on Monday. We're all done.